All right, so today we continue on with lesson 5.2, part 2. So take a look at the problems of the day. I wanted to get you guys to get more practice using synthetic substitution. So I want you to go ahead and solve these. Pause the video. And just to remind you the steps, there's a little set of steps down here to remind you how to solve those. It's important because synthetic substitution we're also going to be using throughout this lesson. To give you a little bit of background also with synthetic substitution, we use it in this lesson for graphing, and we also later on use it to do synthetic division. All right, so it's really important that you understand how to use it and that you're familiar with it. All right, so today we're going to take a look at graphing polynomial functions. And in order to be able to do that, we have to take a look at end behavior. Now, what we know about polynomial functions so far, you can have x to the second power as your highest degree. You could have x to the 10th power. You could have x to the 1000th power. Okay, any whole number exponent will make it a polynomial. Well, that's quite an undertaking to say, here's how you graph. There are so many possibilities, a wide array of choices and types of polynomial functions that we have to look at something called end behavior to give us like a little idea about how to graph it. All right, so end behavior, the behavior of the graph as x approaches positive infinity or negative infinity. Now we all know what infinity looks like, right? It's that little sideways 8. You'll see that in the chart. Now we have 4 classifications we're going to take a look at. Up here we talk about degree being odd. Here, degree being even. And actually, what we just did in the prior part of 5.2, where saying what's the degree leading coefficient, that's going to come back as well. All right, so let's take a look. You can copy this in your notes. Talk about the first one. If the degree is odd and the leading coefficient, the number in front of the variable is positive, look at the end behavior. The end behavior is the little arrows. We start in the down position. We go down to up. Now, what's this little function notation over here? I know it looks very intimidating. So let me explain to you what it means. I'm going to go backwards. I'm going to talk about x. X is this axis, right? So x approaches negative infinity. The little arrow means approaches. So look over here. Watch my cursor. X goes to negative infinity. It's going to the left, right? Let's see what f of x does. We remember f of x means y, right? So once again, x, I'm going to the negative part of x. Y goes down, or negative. That's how we get negative infinity. So do you see the order here? Let's look to the right of the graph, the right half. X goes to positive infinity. It's increasing, increasing, increasing. What happens to my arrow, my y? It also increases or is positive. That's all this notation means. Now, you will have to remember what each of the graphs will look like, but I'm not going to make you memorize the infinity symbols. You'll see, though, in the homework, we actually have you look back to figure that out. So you will need to know enough of it to figure it out. Let's look at the next one. Now, here's what I think is interesting and how I remember. If you can memorize the odd positive, it starts down and works its way up. Well, odd negative flips. It goes up to down. So let's look at the end behavior for this one. If x is negative infinity, so if I'm going to the left, x is negative, my y is positive. Negative infinity, positive infinity. If I go here, x is positive. What happens to my y? It's negative. Positive x, negative y. Now, believe it or not, I think these two are the hardest, so we get them out of the way first. You probably even know, without realizing it, what even positive or even negative is. We spent a lot of time on parabolas, right, in the last chapter, chapter 4, quadratics. Do you remember we had 2 options for a parabola? It either opened up or it opened down. Do you see how odd? One goes down, one goes up, one goes up, one goes down. Well, if you look at the pictures first, if it's even, they both go up, the arrows, or both end behaviors go down. If it's positive, we always used to say, oh, it opens up. If it's negative, we say, okay, it opens down. And make sure in your notes you're copying all this down. You might want to pause the video to mention all the little pieces here. All right, so let's look at x first. X is negative here. I'm going in the negative direction, negative infinity. What happens to my y? My y is positive infinity, negative, positive. I know it's a little silly because it's out of order, but I think it makes more sense looking at the x first. X here is positive, y is positive. Here, x is negative, y is negative. Here, x positive, y is negative. Now, to also give you a little idea, you don't have to necessarily copy this down, but what might a function look like for, I'll show you at least one for the odds. And I'm making this up. Let's do negative x to the third power plus 5x minus 1. Oh, actually, hold on. Let me fix that for a second. Here, my degree is 3, right? It goes from the highest power. My degree is 3. 3 is an odd number. My leading coefficient is 1. 1's a positive number. And maybe you would get something like this one. Like I said, I'm just making these up off the top of my head. If I look at my highest power here, my degree is odd. 9 is odd. I have negative 17. That's a negative number. And then you get the idea about for even. All right, so let's see how we apply this end behavior. Like I said before, end behavior, because there are so many different polynomial functions, there's such a huge array of them, that I need to know the end behavior with the arrows. And just to reiterate, end behavior is like arrow pointing down, up, down, both up, both down. Now, when we're determining graphs, let's put this together with an example like 4. So it says, what is true about the degree and leading coefficient of the polynomial function whose graph is shown? All right, let's look at the end behavior. What do you notice? Okay, in this picture, because you're going to use the chart you copied down your notes, I see the arrows are pointed in the same direction and they're both down. So if I go back to my chart for a minute, it looks like this one. This one is even negative. So if we go back here, degree is even, leading coefficient is negative. Answer is D. Now, I'm not always going to give you a graph. What if I gave you a function, polynomial function? All right, actually, I'm going to switch back to pen for a second. What would the graph look like? Well, first of all, make sure these are both in standard form. I have third exponent, I go 3, 2, 1, none. And I'm going to answer questions based off of the highest one. It's not in standard form. Either write it in standard form or make sure you look for the highest exponent. And then in B, 4, 3, 1, none. Okay, I'm all right too. It's in standard form. So let's talk about that term. There's two things I have to look at. Degree and leading coefficient. You did that in the first half of this lesson. My degree is 3. Now don't forget, besides telling me the number, degree is always, is it odd or is it even? The number 3 is odd, all right? My leading coefficient I know is 5. Now be careful, it's not odd or even for the leading coefficient. Leading coefficient is positive or negative. 5 is positive. If I go back to my graph, or my table on the previous page, odd and positive looks something like this, right? I'm not asking you to make a sketch, but I want to sort of relate back. So if we were actually doing a graph, it would have to look something like this. One arrow pointing down, one arrow pointing up. All right, so let's answer the same questions about B. My degree is 4. 4 is even. My leading coefficient is -2. Don't forget, leading coefficient is positive or negative, not odd or even. Sometimes a lot of people mix up which one's which. All right, it's negative. So if you go back to your chart, even and negative, our graph looks something like this. Now, why is this important? Why are we taking the time to do examples 4 and 5 to use NBA behavior to help us? That's easy. The reason why we are doing that is because now we're going to actually graph them. And when you graph a polynomial function, I can't just tell you, okay, pick 5 points and that'll work out. You need to know roughly what the graph is going to look like to know when to stop. Now, unfortunately, because polynomials have so many different options, I can't give you a method like graphing a line or graphing a parabola. I have to have you guys use a table. That's just how it is because there's so many different polynomials out there. Now, what's the other issue with the polynomial? We need to know the end behavior because we need to know when to stop picking points. I can't tell you, all right, pick 5 points, plot them, you're done. We don't know that. So let's first talk about the end behavior from the chart. And we're going to use end behavior with this piece here, right? Because it goes 4, 3, 2, none. It's in standard form. The 4 is the highest one. So let's see what we get for our degree here. Our degree, let me actually switch this here for a second. Our degree is 4, right? 4 is even, all right? The leading coefficient is -1, so it's negative. This is important because if I go back to my table, even and negative, I know, and I'm going to draw it over here, it's going to look something like this, right? We looked at that from the last one. So it's important to know that. So I'll start you guys off. The first number I'm going to pick, and then I'll walk you through the rest of it. Let's go with -1. Now, if you see, I write graph using synthetic substitution and end behavior. So we talked about end behavior. Now, how are we going to take into consideration substitution, synthetic substitution? You're going to be picking a lot of points. I'm going to be honest with you. You're probably going to be picking at least 5 or 6 points for every problem. It's a little tedious. And I don't know about you, but I think it's sort of difficult if you're going to go through each problem the long way by using direct substitution. Not only will this give you more practice with synthetic, all right, but it's going to actually give you guys a chance to, it's going to be easier and it's going to be faster. The math's not going to be that hard. But be careful, we need a placeholder of 0, right? Because, let me extend the sign here. We have 4, 3, 2, none. We needed a 1 there. So each time you pick a point, you're going to do synthetic substitution for. First number I get is 0. All right, so -1, 0 is here. All right, I need a second point. Let's continue on. Let's do 0. So like I said, synthetic's going to save you some time. Yeah, I know it's still work, but it's easier work, easier math to figure it out. So we do the same thing again. I get 6. All right. And when we graph, just so you know, I know it goes off the grid a little, so this will be by 1s. We're going to count up by 5s. So 0, 6 is here. All right, so let's try another number. We'll go to 1. All right, so we have 2 points so far, -1, 0. And remember, any graph at least has to have 2 points. Now, we know right off the bat, based on our end behavior from here, I'm actually pretty good with, and this will just curve a little with your points. They're not straight lines. I know with my end behavior already, we're pretty good so far because the arrow is pointing down. How do I know when to stop? Well, I can't stop until I get to a point where the arrow or end comes back down. So let's try another number. Keep going in order. Let's do 1. And hopefully by now you guys are getting the hang of it. I'm not going to show you all the synthetic substitution ones because you should be okay. I mean, by the third one that we're doing here. We've practiced like 3 different other examples, so we keep going. And I get 8. Now remember, I said the y-axis I'm counting by 5s because I know they get big along the way here. 5, 8 is about here. So you ask yourself the question, can I stop? Nope, because I'm still doing what? I'm going up. What's the end behavior? I need to come back down. So I have to keep going. Now, I want you to actually make sure you could do synthetic substitution. Like I said, it's going to make your job a lot easier when you have to do a lot of points to use it. Also, I'm going to write down, I'm not going to show you synthetic substitution anymore. Please make sure though that you do it yourself. If you plug in 2, we're going to get 18. All right, so here's 2, 5, 10, 15, 18 is about here. Can I stop yet? Nope, because I'm still climbing up. I have to hit a down point. If I plug in 3, I get 24. So let's plot that point. All right, can I stop yet? Nope, I'm still increasing. Let's try 4. We plug in 4, get -10. So 1, 2, 3, 4, -10. Finally, can I stop? Yes, because you see we climb, 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 and then we come back down. So that's the whole point of knowing end behavior, because there's so many options for polynomials that you need to have a basic idea of when to stop. So it's not always going to be, all right, what do we do, 6 points? Okay, plot 6 points, you're done. You have to know when to keep going and when to stop. So one last example here today. And actually, I want you guys to try to do it yourself. Please make sure you stop the video. I will give you a starter point. Usually -1 or -2 works. Let's start with -2 this time around. And I want you to do the same thing. Now, this time around, I'm not going to show you synthetic substitution. I'm just going to be writing the y's. So make sure you set everything up correctly. So here's the next part here. Hopefully it took a second to set it up. Please make sure you start working on it yourself and not just watch the video. The degree is odd because it's 3. The leading coefficient is negative because it's -1. And I know from my chart this is what my end behavior should look like. So when I plug in -2, I'm not going to show you the work to get in the points, so make sure you actually try them. But I will walk you through the graphing process again. When I plug in -2, I get 3. So here's my point. All right. Then we'll do -1. We're going down the line here. We get -1, get -4. So I know I'm already off to a good start because I'm going, what, down so far? We'll connect them as best as I can on the computer here. And that's looking good so far because my first arrow is pointing up. One thing I will mention before I go through the rest of them is make sure you have the proper setup. Like, I'm not going to do all the synthetic substitutions because I hope at this point you're okay with them. But I will set up the first one for you. This time around, this one doesn't need a 0 because if you look at the original, we have 3, 2, 1, and none. Okay. So let's do the next one, 0. When you plug in 0, you're going to get -3. All right. If if I look, sort of a shape of it, I know in the end it has to go down. So I know I'm not done, because if I stopped here, it would go up. All right, so we'll do 1. 1, I get 0. Once again, can I stop? Nope, it's still going up. So let's try 2. 2, I get -1. Can I stop? Yes, because I went up, up, up. I was waiting for it to drop back down. So make sure you curve the line. Each little piece is a curve. They're not straight. Looks something like this. There's my graph. It looks similar to this one. All right, that's it for the lesson. Homework problem of the day. Then you're going to describe degree and leading coefficient. And then finally, I'm just moving. Let me actually do this real quick, because you can't see the y or the x. 3 graph using synthetic substitution and end behavior. And then here's the function that you're going to graph using synthetic substitution and behavior. That's it for the lesson.